In densely populated urban areas, the overlapping coverage area between low-frequency cells is relatively large and Ka-channel interference is severe. This is a typical application scenario of distributed MIMO, and the maximum gain can be obtained. In common urban areas, the distance between low-frequency base stations is small, and the overlapping coverage area between cells is large. This is a typical application scenario of distributed MIMO, and the downlink throughput of cell edge UEs that experience interference can be increased. Distributed MIMO is based on time domain, frequency domain, and beam domain interference coordination technologies. It increases the throughput of cell edge UEs by using the following technologies. Joint transmission improves the signal quality of cell edge UEs through multi-cell joint transmission. Interference coordination reduces interference to cell edge UEs through multi-cell joint scheduling. Beam domain coordination reduces the resource loss of the cooperating cell involved in interference coordination through joint scheduling on multiple beams among multiple cells. Coherent joint transmission works in this way. First measurement for joint transmission. A UE starts synchronization signal and PBCH block RSRP measurement after setting up a service and sends an event A3 measurement report when a certain condition is met. Second, cooperating cell selection for joint transmission. The nodab selects the cell with the same configurations as the serving cell and the highest RSRP from the neighboring cells indicated in the event A3 measurement report as the cooperating cell. There are two measurements for joint transmission. One is SRS. Independent SRS measurements are performed in the serving and cooperating cells. Another is CSIRs. Joint CSIRs measurement is performed on the antenna ports of the serving and cooperating cells. Finally, multi-cell joint transmission, based on the UE reported SRS and CSIRs measurement results. The nodab determines whether the ratio of the spectral efficiency obtained based on joint measurement to that obtained based on single-cell measurement is greater than the threshold. If it is, the serving and cooperating cells jointly transmit signals to the joint transmission UE. Interference coordination works in 4 steps. Measurement for interference coordination. A UE starts SSB RSRP measurement after setting up a service and sends an event A3 measurement report when a certain condition is met. Cooperating cell selection for interference coordination. The nodab selects the cell with the same configurations as the serving cell and the highest RSRP from the neighboring cells indicated in the event A3 measurement report as the cooperating cell. Interference coordination scheduling. Based on the estimated downlink RBS specific to the interference coordination UE, the cooperating cell does not schedule the RB resources at the corresponding frequency domain position, and normally schedules RB resources at other frequency domain positions. Joint MCS adjustment. The serving cell and cooperating cells exchange scheduling information and separately adjust the MCS indexes based on the scheduling information. Beam domain coordination in distributed MIMO is supported by 8T8R cells. It works in 3 steps. First, measurement for beam domain coordination. The nodab measures the SRS or SRP of the interference coordination UE at each beam of the cooperating cell. Second, beam and UE selection from the cooperating cell for beam domain coordination. The beam and UE that meet the following conditions are selected from the cooperating cell for interference coordination. 1. The absolute value of the SRS-RSRP difference between the beam selected and that accessed by the interference coordination UE is greater than 12 dB. 2. A to-be-scheduled UE served by the selected beam is selected. Finally, beam domain coordination scheduling. On the selected beam of the cooperating cell, the unscheduled RBS and interference coordination scheduling are allocated to the beam domain coordination UE. The unscheduled RBS refer to the downlink RBS avoided for the interference coordination UE.